Okay, so same situation again. We have a quadratic inequality here to solve. Okay, so again, as we've done before, we focus on where this quadratic crosses the x-axis. So we say, look, for the critical points, we consider where the graph is equal to 0. Okay, now I know in this case we don't actually want it to be equal to 0, we want to be less than 0, but we still look at where it's equal to 0 there. It's just like the border, so to speak. So we've now got to solve this, and there's lots of ways of factorizing this quadratic. Okay, now one way obviously we do a lot in lessons is this method here, whereby if it's 4x squared, you put 4x in both brackets. Okay, and then of course over here then you don't put the end number, because there's a number in front here which is greater than 1. You times, don't you? So 4 times 15 is 60. So we think of a pair of numbers that multiply to give 60, and we've got to add up to give minus 23. So if we think of pairs for 60, well, 1 and 60, that's not going to work. 2 and 30, well, that's not going to work. You're not going to get 23 or minus 23 from there. 3 times 20. Now that will work if I make them both minus. So I get minus 23. And of course when they multiply, minus 3 times minus 20 will give you positive, yeah? Because minus times a minus is a plus. So minus 3 minus 20. And remember then with this method, because we times by 4 at the start there, we're now going to divide by 4, and then it kind of like works itself out. So the first bracket, we can't divide that by anything, okay, there. Okay, there's no sort of common factor. So we keep that as 4x minus 3, but the second bracket we can divide by 4. So 4x divided by 4 is x, 20 divided by 4 is 5. Okay, so there you go. Okay, there is the factorized quadratic. So remember then, two brackets equal to 0, so either the first bracket is equal to 0 or the second bracket is equal to 0. So that means then x will equal to 3/4. Okay, when I solve that there, take the minus 3 over, divide by 4, or x is equal to 5. Okay, so that's the critical points. Let's draw the quadratic graph. So 3/4, 5. As I said, don't worry about the scale. This is just a sketch. And of course then we look at what we're interested in. Well, the question asked us to solve the quadratic where it was less than 0. Okay, so we're interested in the x values here so that the curve is less than 0. Well, it's less than 0 between these two, isn't it? Okay, so this is between these two here, yeah? These are the x values. All these x values here produce negative values for that graph. Okay, so we'll start off with saying what x is then. Well, x is greater than 3/4. Notice this time I don't put equals, because we want the quadratic to be less than 0. So it can't equal 3/4, because when x is equal to 3/4, the quadratic is actually equal to 0, and that's no good. We've got to be less than 0. So greater than 3/4. Now if you just leave it like that, then it's not good enough, because greater than 3/4 of course means going on forever, and we don't want all the x values forever. We want it contained between 3/4 and 5. So then we use the word and to say it's got to have this condition as well. X of course is less than 5. Okay, now better situation would be to combine these as we saw in the last example. Okay, so x then is going to be less than 5, okay, but bigger than 3/4. Okay, so we can combine them then overall when we've got a sort of one region there. Okay, however, if this was greater than 0 here, then we'd be looking at two different regions, wouldn't we? So we'd say then x is greater than 5 or x is less than 3/4. Okay, if that was greater than 0, as we saw in the first example.